Hi, I'm Slobodanik from RADX Technologies, and in this video I'm about to continue my demonstration on how to use RADX LibertyGT real-time spectrum analyzer to capture the data of the real-time spectrum monitoring process performed on a Wi-Fi signal. This time we're going to capture the data coming from the real-time spectrogram engine and save them into a file, and afterwards we're going to review those samples of the spectrums captured in a certain period and analyze the results offline. First we're going to set up the system, and since we're monitoring the Wi-Fi signal, we're once again going to set up the center frequency to 2.4 GHz. We'll use 300 MHz of span for monitoring the Wi-Fi signal, and we'll reduce the reference level for monitoring process to -30 dBm to properly capture the signals coming directly from the antenna. Now the results of the spectrum monitoring spectrogram engine can be seen in the lower left part of the screen, where the history of all the spectrums is displayed, and in the lower right part of the screen where the current signal spectrum is also displayed. Now we'll go into the Spectrogram tab and select the method we're going to use for capturing the data into a file. There are three options. You can use the real-time spectrum analyzer to capture the full history presented in the application. You can either control the process or use a timer-based mechanism for capturing the data. In this case, we'll select the timer-based mechanism. Then we're going to set up the file where the data are going to be captured. And in the end, we're going to change the time for the timer and complete capturing process to be 30 seconds. The process of capturing starts with clicking on a Start Saving History button, and you can, again, as in the case of histogram capturing process, stop the process by clicking on the same button or stopping it, or you can wait for the timer to finish the process, which is in this case going to be 30 seconds. When the process is over, the button will restore its initial state. Now the data has been captured into a file, and we can switch to the RADX RTSA replay application to review that. In the RADX RTSA replay application, we'll go to the Spectrogram tab, where we are going to first load the file where the data has been captured. Then we're going to select the method for reviewing the captured data. In this case, we'll leave it on continuous, since we can always switch between the continuous and single mode while we are replaying the data. And we're going to start the replaying process by clicking on the play button. As you can see, the same data are going to be reproduced in the spectrogram history screen and at the same time in the current spectrum screen. In the middle of the process, we'll switch the replaying to single mode, and we'll just continue sweeping. And we're also going to select the frame that we are going to review at the same time with the current frame. And in this case, let's say that we want to see the frame that was captured a second ago at the same time as we're reviewing the frame that is current. And you can see that trace in orange color beneath the current spectrum trace. Now we can start sweeping, and every time we click on a sweep button, the current frame will refresh, and also the frame a second ago will refresh on the screen. Now we'll use markers to analyze the data presented on the screen. First, we're going to analyze, for instance, the data on a frame a second ago. So we'll activate the trace 1, which is the orange trace. We'll enable the marker. Let's say that we want to use the marker 0 as the active marker. We'll reuse the threshold for the peak surge to be minus 85 dBm, and in this case you use no peak excursion, so we'll set it up to 0. Now when we click on the peak surge button, the peak of the actual spectrum captured at point of a time will be found with the marker, and you can read its accurate position and level at a time. Now we can go to the next right peak, for instance, next right, and find the next observable peak in the spectrum and its position. At the same time, we can analyze the trace that is current by switching the active trace to be, again, T0. We're going to change the active marker to be M1. Enable that marker, and let's say perform a peak search in that trace. Now, for instance, we want to measure the difference between the positions of the markers, both in frequency and amplitude. So we'll select the reference marker for marker 1 to be marker 0 and switch the marker mode to delta, and the differences in frequency and level between two markers that are actually displayed on two different traces will be displayed in the lower part of the spectrogram graph.